Assalamu alaikum. In this video, we are going to look at some fundamental concepts and important terminology that we must know to understand the probability theory. Let's begin with the most important one, which forms the core of the probability theory, which is the event. Simply, an event is just a happening of interest. There are many things happening around you. The clock is ticking every moment. People are moving around. Someone is speaking. Someone else is listening. It might be raining outside. A doorbell ringing. The battery of my laptop being consumed, and so on. I might not be interested in each of these events all the time. For example, the clock is ticking, but I might not be looking at the clock for hours. But if there is a deadline approaching, I might be looking back at it every moment, unless I see this a particular time that I'm waiting for, at which time I would say that the event of interest has finally occurred. Other examples could be getting an A grade in the exam. So you might have appeared in 10 different exams, but you are interested in this particular event when you get an A grade. Similarly, although this might seem to be the usual way, seeing cranky children in the gathering, but if this is what you're interested in, then this is an event to you. So you go to a gathering, you see children, none of them is cranky. This means the event has not occurred. You might be interested in finding a friend who has more than 500 in their pocket, or a casualty in a road accident, a phone with a remaining battery time more than 60%. And there can be many other examples. So generally, this happens these days that children, they're never interested in the doorbells ringing. But if they're expecting a delivery, then every doorbell that happens, it is an event of interest to them, and they rush to the doors. Okay, then now the next important thing is how often does this happening of interest occurs, which is the frequency of this event. And we calculate the frequency of this event in relation to the other known occurrences. So say, for example, I'm looking for a phone which has more than 60% remaining battery time. For this, I might check 10 different phones and find only 2 of them which meet this criteria. So I would say that only the event has occurred twice, and it did not occur for the other 8 times. So the relative frequency of this event in this case is 2 out of 10. Now, probability is related to the relative frequency that we have just seen, but formally, it is defined as the likelihood that a certain event will take place. Probability can be defined, can have values which range from 0 to 1, and this is a numeric value that we assign to it. Generally, we say that some events might seem very probable to us, and we say it like that it's very likely for this thing to happen, or it may be unlikely for something else not to happen. But in statistics, we need to quantify this likelihood in this range from 0 to 1, which is actually what we call as the probability of an event. So by this time, you must have guessed that 0 implies there's no chance of this event. यानी कि ये quite impossible है ये वाली occurrence होना, ठीक है? जैसे कि रात को सूरज का निकलना is impossible. So you can give this event a 0 probability. Similarly, it is impossible for a man to give birth to a baby. So this implies that this event has a 0 probability. On the other hand, 1 means certain. Something which is definite, bound to happen, will have a probability equal to 1. And sometimes probabilities can be expressed as percentages. So you will say that it is 100% probable. The chances of this event happening are 100%. For example, it is certain that every human born in this world will eventually die one day. So that means this event of a living person dying one day is 100% or 1. The other values of probability, which range from 0 to 1, excluding these 2 because we have discussed these cases, they tell us how likely or unlikely an event would be. For example, if it is sunny outside, the probability of rain would be low. You might say it's just 30% chance of raining. And if you see clouds outside, you might say that the probability of it raining it now increases to 70 or 80%. Um, the flipping of a fair coin, we know that this can result in either a head or a tail, and both are equally likely to happen because it's a fair coin. So sometimes it might land on the head, other times it might land on the tail. So if you're interested in the event that it lands on head, then the head is up. In that case, we say that it is 50% probable for this event to happen. Another example is, suppose you have a bag which contains three balls. One is red, one is blue, and one is green. And you pick randomly a ball out of the bag without looking. So now there is 1/3 chance of getting a blue ball, 1/3 for a red, and 1/3 for the green ball. The probability of picking a red, blue, or green, whichever you are interested in, because that color would now be the event for you. So if we say that we're interested in knowing what is the probability of getting a red ball, if we pick one from this bag randomly, then there's a 33% chance or a 0.33 probability value that we get a green ball. The next important concept is an experiment, which is simply a process by which an observation is made, or you measure something, or you record an outcome. For example, recording the gender of the next person entering the gate of the university, looking at the clock and noting down the time it tells, observing the amount of the last sale happened at a certain store, recording the color of the car which stops for fuel, noting the number of syntax errors in the programming assignment submitted by a student, recording the favorite food of a university student, and so many others. Every time you're getting some data, it usually is a result of an experiment. So we are conducting experiments every day, all the time, when we are doing things, when we are talking to each other, when we are observing and simply sitting back and observing things. For example, I might be just looking randomly and waiting for a black cat to pass by. This would be an event, and the outcome of it is, if I want to know the number of how many black cats crossed my way that day, it would be the count of black cats. And if I'm only interested in knowing which color of the cat comes next and crosses my way, then it would be the color. So we are making observations, we are doing experiments all the time. Now, the concept of a random experiment. Up to now, we know that the experiments are simply processes by which we record some observation. We get some data, we get some findings. And they're called random experiments when the outcomes of these experiments cannot be guaranteed. Although we know that there can be certain outcomes which may happen, but exactly which outcome will happen in the next time you make the same conduct the same experiment, you cannot guarantee that in advance. And it is only certain probability associated with this kind of outcome happening if you're making an observation. So such kind of an experiment is known as a random experiment. So tossing of a fair coin, we know that it can result in one of the two possibilities. Either it is a head up or it is a tail up. So we know that since both of them, it being a fair coin, the probability of a head or a tail is 50%. But what exact outcome would it be when I toss it next? I do not know that until I actually conduct that experiment. Similarly, someone might be they might be very good at aiming, but still hitting a target, you never know if the outcome would be a hit or a miss. There always is going to be a probability. The probability of hitting might be very high, but still there is a chance of missing the target. The same experiment of recording the color of the car which is stopping for the fuel. It could be red, black, blue, and all other possible colors of the car. But what exact color it would be for the next car which stops by, you do not know until that happens. So this is what makes it a random experiment. The outcome of it is not guaranteed. An experiment results in an observation made or an outcome. such as the color of the car. So the outcome or observation is the color. A possible outcome of a random experiment is called a simple event, such as in this case, गाड़ी का रंग is a simple event. अगर red color की गाड़ी है, तो it means this outcome red is one simple event that can happen as a result of one time this experiment conducted one time. The set of all possible outcomes from a random experiment is called the sample space. अगर हम गाड़ी वाली एग्जांपल लें तो इसमें all possible colors that are there for cars make up the sample space. So एक दफा एक्सपेरिमेंट कंडक्ट किया, जो नेक्स्ट गाड़ी रुकी उसका कलर नोट किया, इट कुड बी वाइट, नेक्स्ट टाइम इट कुड बी रेड, नेक्स्ट टाइम इट कुड बी or any other possible color of the car, but the total sample space, all the possible outcomes for this experiment are only the colors that are there in cars. So a simple example could be, which makes the concept clear, is recording the gender of people entering the university gate. This can have only one of the two possibilities, a male or a female. So the sample space for this consists of two possibilities, two simple events. We are actually focusing here on the simple event. The concept of simple event is one possible outcome from an experiment. So here, one simple event is male, the other simple event is female. However you record these values depends upon your notation. You might want to record it as M for male and F for female, or maybe encode it as a numeric value, 0 for male and 1 for female. But whatever it is, we know that it is going to be just one of the two possible outcomes, a male or a female. So both of these make two simple events for this random experiment. We discussed this example. Then recording the age of a person wearing a red shirt at some place can result in an outcome of from 1 to 200 years. Of course, assuming that people do not live beyond that age, then we have the possibility of getting a 1, 2, 3, 4, 5, up till 200. So these are, each one of this, each one value from this range is one simple event for this experiment. When an experiment, random experiment is conducted once, it results in one observation or one reading. And that is one simple event. For example, if we toss a coin, single coin, the experiment, the outcome for this experiment would either be a head or a tail. But if our experiment is different and it says that the experiment is to toss 3 coins and note whatever outcomes are there for each of them, then our if simple events are not going to be just one head or one tail. It's going to be 3 of them. And we can have these combinations. We can have all 3 tails, we can have all 3 heads, or we can have any other combination of heads and tails for 3 coins. So the simple event in that case would be like the ones you see here, and not like this one. And again, if we change it to tossing 4 coins, it would be 4 things together. And of course, the number of possibilities, possible outcomes would increase. Now, one run of an experiment is called as one trial. So if you're running an experiment, conducting an experiment 10 times, these are actually 10 trials that you're making. And for every trial, you get one outcome, which is one simple event from the sample space. And if you're conducting it 10 times, you are getting 10 simple events or 10 outcomes from those experiments. In simple words, those are 10 observations being made. Example is recording the number of errors in programming lab work submitted by a student. So if I do it for one student, it is one trial, and I get one number, which is the number of errors. And depending upon what range it could be, for example, at the most, if the errors could be, if there are only 100 lines of code and you cannot have more than 400 errors, then maybe the range, if you assume it to be from 0 to 400, then I expect one value from 0 to 400 for one student. And if I do it for 10 students, I'm conducting this experiment 10 times, which means there are 10 trials of the same experiment, and I will have 10 outcomes from one outcome from each of these, and 10 outcomes from 10 trials. Now, the concept of sample space, we have discussed it briefly earlier. Sample space is a set which consists of all the possible outcomes from an experiment. So if it is tossing of a coin, we expect either a head or a tail. So the sample space in this case is consists of two outcomes, a head or a tail. And when we say that sample space is a set, all the operations that apply on a set apply on sample space, which means we can have union of sample spaces, two sample spaces for two different experiments, intersection, complement, we can take differences, etc. And also the most important things, we know from our understanding of sets that the elements of a set, they need to be distinct. So it's head just once. We cannot have two elements with the same value. Sample space is expressed in set notation using the symbol S. It can be finite or infinite. For example, recording the numbers of cars passing a certain square every day can result in one of the possible values, 0, 1, 2, 3, 4, and infinite, because we do not know. There's no end to it. So in this case, the sample space would be infinite. But observing the face value when a fair die is rolled, we know that we can have only one of the 6 possibilities. So it could be 1, 2, 3, 4, and 5 or 6. So in this case, the sample space is finite. Again, you can have continuous values also. If you're recording the height of students, then in this case, the sample space would have outcomes. It will be infinite because there are infinitely many possibilities, but the data in this case would be on the continuous scale. Such as here, recording the length of hair of a girl student. Now, since when we have continuous valued data, in that case, listing of all the values sometimes becomes quite difficult. So we can write it in this set builder notations, the way it is done here. X such that X belongs to the real number set and X is greater than 0 and equal to 0, because these days we might have boy girls also. Then sample space can have categorical outcomes also, such as in the case of the balls in the bag example. We had 3 colored balls in the bag. So the outcome would be red, green, or blue, and it can be written like this. So either you list all the values in the sample space if they are finite and you can easily do it, or else you can use the set builder notation to define it if it is continuous and you want to define it as a range. Now, the examples of sample space include if we flip 2 fair coins, again, the experiment now is to flip 2 coins and the outcome is going to be recorded accordingly. So it's either both heads, one head and one tail, the first one head and the second one tail, the second one head and the first one tail, or both of them being tails. So these are 4 possible outcomes, and the size of the sample space is 4. So when we run this experiment, we expect one of these 4 outcomes to be there for every trial. Rolling 2 dice and recording the sum on the faces. Now we need to just take some time and understand this. Now, when we're rolling 2 dice, we know that each of those die can have values from 1 to 6. And the experiment now is not to note the face value, whatever value comes up on the dice. It is to record the sum of those values. So we know that the least numbers that we can have on the dice, both of them are 1. So the least sum that we can have is 1 on the first die and 1 on the second die. So we get a 2. Then keeping this one fixed for the first die and trying up all the other possibilities on the second die, we get 1, 1, 2, 1, 2, 3, 1, 3, 4, 1, 4, 5, 1, 6, 7. And after that, we change this first one to the next number. So now we have 2 and 1. 2, 1 is 3. So we know that since we are writing it as a set, we cannot have the same value repeated in the set. So this value is already covered with 3. We see 3 ones. Then 2, 3, 2, 4, 2, 5, 2, 6. Now 2, 6 is 8. And this value is already not listed. So we add an 8 to it. Then we have 3, 1, 3, 2, 3, 3, 3, 4, 3, 5. 3, 5 is 8, which is already included, but 3, 6 is not included. So now for 3, 6, we have 9. For 3, 7, we have 10. For 3, 8, we have 11. And we do not have beyond 3, 6. 3, 6, we have 9, and that's it. Next, now we change the value of the dice, the first one. which we were holding at 3 earlier. Now it is 4. 4, 1, 4, 2, 4, 3, 4, 4 have been covered. Even 4, 5 is covered. 4, 6 is not covered because 10 is not already added. Because the last value we added for the previously of listing of the values of the sum, we had 9 added to the set. Now we have 4 on the first die and 6 on the second die. So this is 10, we add that. And the same process will repeat until we get all the combinations and find out the sum, and we get this set. So these are the possibilities when our experiment consists of rolling 2 die and recording the sum. Recording the sum of ages of couples entering an 18 plus gathering. So we know that we can have both of them have ages 18 and above. So we try to write all the possibilities. And since again it is a sum, so we can either write, we cannot possibly cover all the possibilities because there are going to be so many options. So we either write it as in the set builder notation, or we can write it the first few values and then these dots to suggest that the values continue. And they go up to the infinity. So the first value would be 18, the first person, 18, the second person, we get it 36. Then 37, 38, 39, 40, and up till infinity. Recording the probability of rain predicted by the meteorological department for each day of the January, day is missing here, for each day of the January. This we can write as in the set builder notation, because now the probability values, they range from 0 to 1, both inclusive, and there are infinitely many possibilities of this. So we have x such that x belongs to real number and x lies between 0 and 1 inclusive. Recording the months of births of people entering a shopping mall. Of course, we can have only 12 months. So the outcome for this experiment would be January, February, March, April, May, and all these months. You can write them as January complete, or Jan, or even J, or you can encode it. You could have even written it as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then you could have specified the a key that showed the mapping between the numeric encoding of the value and the actual value. So recording the first letter of person's name, we know that the letters can vary from 0 A to Z, and we listed those here. The sample, it is important to correctly first identify the sample space, and which involves that you enlist all the possible outcomes from an experiment, and you do not miss out any of those outcomes, because later the probability is going to be calculated based on the sample space. So it is important that you take some time and very carefully define your sample space and do not miss any of the possible outcomes. And sometimes the experiments that we're conducting become very complex, such as flipping 4 coins or rolling 4 dice and then finding out the sums and all of that. So we need to list all possible outcomes and then build our sample spaces. One of the ways to do this is to use a tree diagram. So for example, see here, a combo meal is to be made by choosing one item from burger, hot dog, and pizza, one item from water, milk, or soda, and one item from cake or ice cream. So we know that there are, we can calculate the number of possibilities that can be drawn from this, which is 3 possible items in the first place, 3 possible items in the second place, and 2 possible items in the third place. So this is a 3 into 3 into 2, which is 18. So we expect 18 possible outcomes from this experiment. And this can be done using a tree diagram. So in the first place, if we get a hot dog, we have 3 possible outcomes in the second place, which are milk, water, and soda. So we draw these branches here. Then again, for every of these outcomes, every of these possible, these are not the simple spaces, simple events at this point, because the simple event is this. Our experiment consists of completing this experiment by choosing each one of these categories. So for every each one of the items that we choose in the second place, there are still 2 items to be chosen from the third place. So here we can have one possibility. We write it like this. We have the one possible value on the first place and all the possible values on the second place in form of tree. And then for again, on the next level, all possible values on the third place. So we get ice cream cake here, ice cream cake here, and ice cream cake here. And now we can see that we can read this tree from here to here, following these branches to make one simple event. It will be hot dog, milk, ice cream, hot dog, milk, cake, hot dog, water, ice cream, hot dog, water, cake, and so on. Then we can do it for the second. Here we get the first six possible outcomes from this experiment. Then we do it for the second option in the first place, which is burger, and we repeat the same thing. Because in the second place, again, those are three possibilities. And in the third place, there are two possibilities for each of the three possibilities and for this new possibility at first place. Then we have another six outcomes here. And then finally, the third one, where it's the first option is pizza, and again, three options, and then two options for each of them. So we have a total of 18 outcomes listed here. And these are the simple events, and this forms the sample space. So if you have a complex experiment which has stages in which the items are to be combined, then you may draw a tree diagram so that you do not miss out on any of the possible outcomes.